to my first video of M cubed with Sylvia. Now, if you haven't read the channel description yet, you're probably wondering what M cubed means. Well, I'm going to explain that right now. So, in mathematics, M cubed is equal to 3 M's multiplied together. And for my channel, each of those 3 M's represent a certain something. And do you want to know what they represent? Well, I'm going to say it anyway. The first one represents math, because some of my videos will be about math. The second one represents music, because some of my videos will be about music. And the third one stands for more, because I'm not just going to do math and music. I like to have a variety of things so my watchers don't get a little teensy bit bored. Like, yawn, it's probably a math or a music, boring. So, I have more. Now, let's get started with today's topic, unit circles. So, let's start with explaining radians. I don't know any symbols for radians yet. Now, most people are used to using degrees as the unit of angle measure. Degrees. And most people know, when they're using degrees, that there are 360 of them in a circle. Well, there are 2 pi radians in a circle. And it seems strange to have an irrational number, doesn't it? Well, it's because it's a circle, and I'll show you a little explanation why. So we have a circle with center O and radius 1. And we have an arc with length radius 1. Let's draw the second radius. Looks almost like a rounded equilateral triangle, right? Now this angle theta is equal to 1 radian. You notice how the words radian and radius are quite similar. Now, our second topic is knowing what a unit circle is, and that is not a very good y-axis. That's a coordinate plane. Oops, that's not y. That's x. That's y up there. And here's our unit circle. And it has the equation of x squared plus y squared equals 1. Origin, radius 1. You're probably wondering why this is if you haven't learned it yet. So I'm going to explain it right now. This is 1. For the sake of it, this is not y anymore. This bit is x, this bit is y. And in the Pythagorean theorem, which states that in a right triangle, any right triangle, with legs of length a and b, and a hypotenuse of c, that a squared plus b squared equals c squared. And then that can be a. X is equal to a and y is equal to b. And we can substitute, and well, c is equal to 1. And we can substitute its values into this equation to get this one. Not so hard, right? Now, let's start finding some common angles in terms of radians. So we have a unit circle centered at O. Doesn't look very centered at O, but it is. And we have some common angles. Oops. And also in this quadrant, and this one, and this one. And we're going to start, this is 0, and we go counterclockwise as a convention. So this angle right here will be 45 degrees. And you know how a circle is a total of 2 pi radians? And a full circle is 360 degrees. So that means a 180 degrees, or straight line, would be pi radians. So this would be pi over 2, because this angle right here is 90 degrees. And this would be half of pi over 2, so this would be pi over 4. These, in terms of pi, are all in radians. Of course, if you went clockwise, then all these values, this would be pi over 2 instead of that, and it would be negative pi over 2. And this would be negative pi over 4 right here. But we're going counterclockwise. So this angle right here is 30 degrees. It is 1/3 of this angle. So 1/3 times pi over 2 is equal to pi over 6. And this over here, 60 degrees. And it's twice of this. So 2 times pi over 6 is pi over 3. And then we can keep adding, so we can draw this line is this angle theta. Theta is 30 degrees. And then we can keep going like this through the entire circle to find all the radian values. Just gonna fill them in. This would be 2 pi over 3, 3 pi over 4, and 5 pi over 6 right here. And right here will be 7 pi over 6, 5 pi over 4, and 4 pi over 3. I'll erase this arrow because that makes everything very squeezy. This would be 5 pi over 3, 7 pi over 4, and 11 pi over 6. And that's the entire circle in radians. Now we should find the coordinates of those significant points. And once again, the Pythagorean theorem is here to save the day. Centered at O and the radian of 1. I'm going to put it there because we're going to need to use this line. So we have the common angles 30, 45, and 60, because those give us some special right triangles. Okay, so then we can draw this radius of 1, and these is a right angle. So this side and this side will be the same, since this angle right here equals 45 degrees, not radians. I'm just going to use degrees because it's easier for most people to understand. So this will be 1 over square root of 2. In this case, we don't rationalize the denominator because that makes it a little easier to work with. I'm going to explain rationalizing the denominator in a future video. So that makes this 1 over square root of 2, comma, 1 over square root of 2. I'm going to erase this triangle because it's going to interfere with the others. The ones that I did for 30 degrees and 60 degrees. Okay, now we can draw the one for 30 degrees. This is 1. This is a different angle theta. And now angle theta equals, no, not 60, whoops, equals 30 degrees. That's angle theta right there. And for 30, 60, 90 triangles, that one would be half. that would be square root of 3 over 2. Gives us our coordinates. Square root of 3 over 2, comma, 1/2. Now we'll erase this triangle again. And draw the one for 60 degrees. That's also 1 right there. This is angle theta. And this time angle theta is 60 degrees. So this would be 1/2 square root of 3 over 2. So this coordinate I'm going to write up here would be 1/2, comma, square root of 3 over 2. And then we can reflect it onto this side, and onto this side, and here. So for this quadrant, if this was x comma y, this would be negative x comma y. This would be x comma negative y. This would be negative x comma negative y. And given these values, we can use these 3 things to figure out the coordinates for the major angles in the other quadrants. And then this is trigonometry, right? Trigonometry is about sine and cosine and things like that. Well, there is a relationship to sine and cosine. Another unit circle. Topic is unit circles, so of course there are a lot of unit circles. Origin 1, any angle theta, and we can drop the perpendicular down here. And this will not be 1 anymore. This is 1 because this bit plus this bit right here is 1. We're only interested in this bit, and that's x. This is y. Fits the equation up here, doesn't it? And, well, sine is opposite y over hypotenuse 1. So y over 1 is just y. So the y coordinate will be sine of theta. And cosine is adjacent over hypotenuse. Adjacent over hypotenuse. And adjacent would be x. Hypotenuse is 1. So adjacent over hypotenuse would once again just be x. So this is cosine theta. And you might have learned the trigonometric identity. Sine square theta plus cosine square theta equals 1. If you haven't, well, now you know. You're probably wondering why this is true if you don't know yet. So, we can use this equation. Yes, the equation of a circle is also pretty useful in the topic of unit circles. So we have sine square theta plus cosine square theta is equal to 1. And then we can also use this fact and substitute it right here to get cosine square theta plus sine square theta equal to 1. And these two are the same because of the commutative property of addition, which states that A plus B equals B plus A. And that's all for this video. If you have any questions, feel free to post them in the comments. And make sure to hit like and subscribe if you enjoyed. And then hit the bell so you'll get notified every time I make a new video. Thanks and bye!